Okay, so this lesson is going to be looking at negative integers represented in binary. So basically we're talking about negative numbers but being shown with ones and zeros. Now there's two different ways that we can show negative numbers in binary, or two that you need to be familiar with. One of them is called 2's complement and the other one is called sign and magnitude. And you need to be able to convert between binary negative numbers into binary decimal numbers and vice versa. So to start with then, we're going to have a look at something called sign and magnitude. So, referring to two key terms that we looked at last lesson, we've got LSB and MSB. We've obviously got LSB, meaning the least significant bit, and that's the one that's furthest across on the right. We don't need to worry about that one too much today, actually. And then we've got MSB, which is most significant bit, and that's the one that's furthest to the left over here. That's our most significant bit. So when using sign and magnitude, what we do is we change, we don't change, we use the most significant bit to tell us whether the number is going to be a negative or a positive. So you could think of this box here that I'm circling with the mouse as either having a plus or a minus in it. Now in order to represent a minus, we use the number 1, and to represent a plus, we use the number 0. So if we have a look at one example of that to start with. So to represent minus 13, the little 10, remember, just tells us that that's a decimal number, not a hexadecimal number or anything like that. So minus 13, like normal numbers, decimal numbers, in an 8-bit binary number, you would first write 13 in binary. So we just do what we would normally do, forgetting the minus to start with. So nice and easily, we would write down 0, 0, 0, 0, 1, 1, 0, 1, because we need an 8 and a 4, which makes 12, and we need another 1, which makes our 13. Then all we do is we decide, is it going to be a negative number, which it is, so we need to flip our most significant bit to a 0 to tell us that, to a 1 to tell us that this number following is going to be a negative number. Therefore 1, 0, 0, 0, 1, 1, 0, 1 is minus 13 using sign and magnitude. The problems with this are that you can only represent 0 as both a negative or a positive number. Okay, so that's one problem that you might need to, if it asks you what some of the issues are, then that would be one issue. The other issue is obviously you're reducing the amount of numbers you can store. We can't now store anything above 128 because we need to reserve this bit over here to tell us the sign and the rest for the number. So looking at the second way of doing this then, this is called 2's complement. Slightly more complicated, but nothing too cosmic. So if we are representing a negative number, e.g. minus 6, first write out the normal, the positive number of this value, 6 in this case, in binary. So all the zeros up until 4 and 2, which of course tells us we need a 4 and a 2, which equals 6. What you then do is, starting from the right over here, you leave all the numbers the same up to and including the first 1. So the first number here, 0, we leave that as it is. Our next number is our first number 1, the first one that we've hit, so we leave that one the same. From that point forward, this is where we need to do something. So we leave these two the same, as I've just said, but now we're going to flip all of these numbers. So previously that one was a 1 and these were all zeros. If I flick back to the previous slide, you'll see that. So you can see it was a 1 and all the zeros. Now we have a 0 and all the 1s. So very quickly again, we leave all the numbers the same up to and including the first 1, and then we flip all the rest of them. We'll do another example of that in a second so that you get to see that working again. So therefore minus 6 in binary is that in 2's complement notation. What's the main drawback of representing negative numbers in a fixed size, for example 8 bits? As I've just said, you are now limited to not being able to have quite the range of numbers that you used to have, because we need to reserve some of these bits to tell us whether or not it's a positive or a negative number. So you're going to be working through your OneNote in a moment. If I just flick to your OneNote, you can see that you're going to have to do a little starter task, which is some arithmetic shift from last lesson, so you might need to go back to lesson 5 to have a look at that. You're then going to make some notes on how to change numbers into negatives using sign and magnitude and 2's complement. You are then going to explain how to convert 16 into a negative number using both sign and magnitude and 2's complement, so it's like doing this again but in your own words. And then you're going to have a go at converting these numbers using the 2 different methods. Now this is a spreadsheet that you may or may not be able to open depending on the device you're working on. If you can open this spreadsheet, perfect, complete it, it will pop up and tell you whether you've got it correct or not. If you can't, there's many ways that you could go about this. You could do it on paper, take a photograph, you could use the draw tool and just draw it across the top here. You could copy and paste one of these tables into Word and do it in Word, as long as you have a go at these questions. Okay, and you can see the numbers that you're trying to convert to over here. I just needed to scroll across a little bit. Now before I sort of let you go and have a go at doing this task, we're going to go through one more example just because I think it might help some of you that are struggling. You may also need to watch this video twice because this is something brand new and it might take a couple of attempts before it clicks in your mind. So your task 2, as you remember just then, was to convert the number 16 to a negative number. Rather than doing your example for you, I've just picked another number that we're going to have a go at doing, so that you still have a go at doing 16 on your own. So let's do minus 28 as an example. So using sign and magnitude then, firstly we'll use this row here as our step 1. We just need to write 28 out as a binary number. Now we can't fit 128 in there, or a 64 or a 32. We can fit a 16 in there, and then if we also have an 8, that takes us up to 24. We've got 4 left, so we can have a 1 there, and then those can be zeros. At this point, check you've got this bit right. There's no point moving on until you guarantee this is right. So 4 plus 8 is 12, plus 16 is 28, and that's what we were trying to produce over here. As it's a minus number, and we're using sign and magnitude, our most significant bit is going to tell us if it's a positive or a negative. So for a negative number, remember that the most significant bit needs to be set to 1. We then carry on with the rest of our binary number just copied from above, and therefore using 2's complement, that would be our number. Okay? Using sign and magnitude, sorry. It's very early. 2's complement. So we're going to do the same number again, minus 28 as an example, but this time we're going to use 2's complement. So we've already done step 1 before. We've already converted it into a normal positive number. So we know that that's correct. We've got a 16 and a 4, which is 20, plus our 8 is 28. So using sign and magnitude, we're going to start from the right, and we're going to leave all the numbers the same up to and including the first 1. So we've hit our first 1 and we've kept it the same. Everything after that point is inverted. It's flipped to a different number from 0 to 1. Okay, so using 2's complement, that would be minus 28. So what I want you to do is on your OneNote, finish off lesson 6.